All right, so next question. Again, we've got two ropes or two supports. This time we have multiple masses that we're trying to support. The good news here is that we have symmetry because the person is standing in the middle of the platform. Um, if the person were standing more to one side than the other, then we'd have a lot more work to split up and see what's happening. But here, everything's shared equally. You may also notice that compared to question three, there is no angle here. And so, that makes it a lot nicer. We don't need any trigonometry to work on this one. All right, so what we want to think about here is we need to think about our forces that are going in opposite directions, right? So we talked about reactive forces before. When we had one rope, there was a weight that was down and a tension that was up. But now that we've got multiple things in multiple directions, more weights because they're the separate masses, more forces up because we've got different tensions, or rather different ropes creating tension. We need to almost do like a net force question again. So first we want to think, all right, what's our F down? What's our total force going down? And that's going to come from the weight of the worker and the weight of the platform. And for this to be balanced, for everything to work properly, that has to be equal to whatever forces I have going up. So we have to ask ourselves, how big is our F up? Where's our F up come from? Why do we have an F up? So the forces in the upward direction this time are going to come from the tension in one rope and the tension in the other rope, which presumably we don't know either one and we don't know the relationship to each other, but we'll see in this particular question that we can do a little bit better than normal. All right, so the unfortunate thing about this question, when we're looking at this initially, is that if we check out the units, they don't line up with what we're looking for. We've got kilograms here and kilograms there, and eventually we're trying to get to newtons. You have some options as to when you plug stuff in and exactly how you do it. But, like the other one, I think we can kind of do this in line with the question. So if we take and we multiply this by gravity, so multiply by 9.8 meters per second squared, my decimal got kind of eaten there. Then we can get that the weight of the worker, remember kilograms and meters per second squared, that gives you newtons, will be 1881.6. Turns out it doesn't matter how long the platform is because everything's symmetrical. But then here we'll want to do the same thing. We've got the mass of the platform, mass because it's in kilograms, and then we want to multiply by gravity, and that will give us that the weight of the platform. So now we use a force to find a force for going in the right direction. That's going to be 3439.8. All right, so that's as much as we can do for right now, because unfortunately I don't know either of these tensions. So let's start plugging stuff in, kind of see where this is going to go, if we can do anything helpful right now or not. We know that the weight of the worker is one of the things pulling down. So we'll plug that in, and we know the weight of the platform is the rest of what's pulling down. So yeah, we have that number 2. And everything else is pulling up. Now, because the person's in the center of the platform, again, that means we don't care how long the platform is, because the person is just an equal distance from either side. What that means is that we don't know what these tensions are, but we know that they're the same. So I don't need to put 1s and 2s or A's and B's or anything on them. I don't need to differentiate between them now because they're going to have the same value. And where that's helpful is, I've got half the stuff to go find. Ends up being about 1/3 of the work. It's a lot more complicated when they're different. But that also means that I can put them together. And be careful, common mistake is students will say t squared when they get to this part, but t plus t, how many t's? There's 2. All right, then our combined force that's coming down, which again has to be the same as combined force going up. So I need a number for this first part. Adding those together gives us 5,321.4. And then finally, we have all of our little issues worked out. We know everything we need to know to find the tension. So divide by 2, divide by 2, shared equally, so each rope's going to have this same tension, and that tension is going to be 2,660.7.